Welcome back to A Neighbor's Choice Radio. We are live on FM, on AM, on our podcast. We're also available on Rumble. Remember, if you want to listen live, you can go to aneighborschoice.com, click on the audio player from 5 to 7 p.m. Eastern Time. You'll catch this broadcast. And if you miss it when it's live, of course, I recommend that you subscribe to our Rumble. Search for A Neighbor's Choice on Rumble. Search for it on whatever podcast platform. Just search for my name, David Gornoski. We use my name for that because of the various different programs we do in addition to A Neighbor's Choice, including a kind of sub-series that we've done, a kind of show within a show that we've done for years, since the very beginning of this broadcast. As you understand it, A Neighbor's Choice, we do a series that we're doing right now called Science and You. And that's where we take a break from politics and culture and the lunchroom drama that is that world, and we turn to the world of science and engineering, new physics, new chemistry, new ways of powering our cities, powering our cars, powering our homes, new ways of thinking about these things. And to do so, we have with us our chief science advisor and physicist, Dr. Yu. How are you?
Thank you, David, for having me on. I'm doing great.
Very good. Let's look at this story here in Yahoo. Fusion power is approaching reality thanks to a magnetic field breakthrough. Fusion power may be more realistic prospect than you think, they say, as Motherboard reports. Researchers at the Energy Department's Lawrence Livermore National Laboratory have discovered that a new magnetic field setup more than tripled the energy output of the fusion reaction hotspot in experiments, approaching the level required for self-sustaining ignition in plasmas. The field was particularly effective at trapping heat within the hotspot, boosting the energy yield. The hotspot's creation involved blasting 200 lasers at a fusion fuel pellet made from hydrogen isotopes like deuterium and tritium. The resulting X-rays made the pellet implode and thus produced the extremely high pressures and heat needed for fusion. The team achieved their feat by wrapping a coil around the pellet made using special metals. The notion of using magnets to heat the fuel isn't new. University of Rochester scientists found they could use magnetism to their advantage in 2012. The Lawrence Livermore study was far more effective, however, producing 40% heat and more than 3 times the energy. Dr. Yu, what's your takeaway from this story?
Well, so this is some kind of a new advancement, on the fusion research. So what's new here? The problem with all the current fusion experiment is we have difficult to create high heat. So the problem is when the heat is too high, you cannot contain the heat within the container, and it burning through the facilities, right, the containers or something, and otherwise you do not generate enough heat at the level to create a fusion, sustaining fusion reaction. And in this story, they discover a new magnetic field setup. Basically, they use a magnetic field to generate heat, right? But so how to set up the magnetic field in order to triple the energy output? That means create much higher temperature, right? And to the level called the self-sustaining ignition in the fusion reaction in plasma. Self-ignition means you can sustain, self-contain, self-generate fusion within with high heat and within the containment of the facility. So what's new? So they find a new way to set up a magnetic field. So they basically wrapping special metals around this called pellet. The pellet contains two type of hydrogen isotope fuels. So deuterium and the deuterium, they contain this one. But in order to generate high heat, so they wrapping it around with a magnetic coil, and then use blasting like 200 laser, blasting the heat, the laser light is generate heat, right? Blast heat, and they can't use this X-ray, made this pellet high heat, make this pellet implode. And that's when you implode, it's like an explosion, right? And it create high energy and high pressure, high heat. So that's what they say. However, if you read to the very last paragraph, it says the practical fusion reactor are still many years away. Now we back to the same side. So the output, even the output is much bigger than previously, but still far less than the energy required to create self-sustaining reaction. So basically, say we made progress. We can generate 3 more times of energy output with the current setup, with the current device, right? However, we're still many years away. I think they realize even though we can generate high heat, does not guarantee we can generate a self-sustaining fusion reaction. For our long-time listener, so you may familiar with, I always said the current approach is a wrong approach to fusion reaction. You cannot just say use high heat, generate many times higher than at the center of at the temperature of the sun, and try to create a fusion and sustaining fusion for the future. I believe this is the wrong way. It's not going to be successful. So even though they tried many years, right? And I believe so we have to update our knowledge and gain true and inside of the. We have to learn the inside of fusion reaction, the fundamental the principles. Right now, we are guided by fusion theory, which I believe is a complete fraud. It's a wrong theory, just because we are not fully understand the fundamental physical reaction process. So that's why I do not believe this process will work. But of course, during this process, people may create some kind of new technology. I'm not. I do believe that could happen, but not for the purpose of fusion reaction.
Yeah, it's one of those things where they're still not getting the principle right, and it's misdirecting their efforts, right?
That's correct. Yes. So to say that simply, the principle was wrong. Consider fusion use high heat to fuse them together. This is a wrong concept. We know you can fuse together use temperature, right? So 2 pieces of metal, you heat them, but those heat you consuming more heat than you generate output energy, which I believe in this case is the same thing. You use 200 laser beam, blasting there's a few pellets. You try to force this called the 2 type of hydrogen isotopes, right? The deuterium and deuterium, make them so hot and make them fuse to create some kind of called helium particles or something, and to release heat. That's a wrong concept. It's not going to be successful.
Why do you think they don't ever try to take a gentler approach to maybe? I guess it's because they can't conceive of fusion any other way, right? In terms of
right, because number one, the current called what is a hydrogen bomb, right? So that's basically you wrap a atomic bomb inside. let atomic bomb exploded and then trigger, use atomic bomb, a trigger higher level, a deeper level explosion, and create called a hydrogen bomb. Basically it's basically almost order of magnitude higher than atomic bomb. So you have to use that much energy. So that effect. So make people think about it. So if I use higher heat, higher energy, to make two type of materials, hydrogen isotopes, deuterium and deuterium. So basically we think, if we can make a nuclear hydrogen bomb work, you use high heat. So then we can make, use high heat, make this deuterium and the deuterium react and fuse them together to release energy. No, that's a different thing. That's a totally different thing. So hydrogen bomb is not because of fusing lighter elements, say deuterium and deuterium, and form heavier elements, say helium, to release more heat. That's the current understanding is to lighter element fuse together, and they release a huge energy by a byproduct is form a heavier element, so like helium. That's not the case. So what I believe, the so-called hydrogen bomb, so is bigger than, is more. It's only because it's still nuclear fission. It's still split nuclear atoms or split nucleus. It's a split. Actually, it's totally split them and make a smaller fragments, and then you generate more energy, just a deeper level, just more splitting instead of split atoms. Say. What is it? Just split to the level, say, molecules are related by atom, so element fly away. Now we split the atom into not just electron and nucleus, but inside of the nucleus split the neutrons, protons, neutrons, split the nucleus, just split the level too deeper. So then we generate more energy. However, so whenever we measure nuclear reaction, hydrogen, fusion, we always have a byproduct of helium. It's heavier elements than the split like a neutron protons, right? So where did that come? I believe those things is the byproduct is after you split the nucleus, all the particles in the nucleus are charged particles. We're talking about was a neutron, maybe using a neutral, but it still has a magnetic field. Okay, even neutron has a magnetic field too, and all these particles after they split. What is that? They bombast, split as a fragment. After them cooling down, these are charged particle. After this particle cooling down, so now they form a neutral particles. Because they attract positive, attract negative, from the bigger, heavier elements. So that's the time you have a helium formed. So that's after you release all the energy. That means after the bombastic, the splitting of the nucleus, and then after energy release, after those particles slowing down, and then they gradually cooling down. Now they can attract to each other because they are all charged particles, right? Charged particles basically based by magnetic particles, so they can positive and negative attract them, and forming a heavier and a lighter, heavier and a neutral lighter particle becomes stable. So that's where helium forms. So in our case, we try to use a small amount of deuterium and tritium. Use small amount, force them together? No. Your only thing is make them, higher motion and make them actually against each other, separate them each other, bigger. So in that process, you're losing more energy. Then you try to achieve, say, the misconcept is if we fuse them together, we can achieve higher energy. That's a wrong concept. The only way is you split them at a deeper level, and then you achieve more energy. And after those those deeper level, those charged particles cooling down, after blast cooling down in the air, now they started to attract to each other and form heavier particles.
Yeah, what do you think about this story, Fighting Cancer with Magnetic Bacteria? That's SciTechDaily.com. Says researchers are working to determine the best way for anti-cancer drugs to get to the tumors they are supposed to treat. One option is to utilize modified bacteria as ferries to transport the drugs to the tumors via the bloodstream. ETH Zurich researchers have now successfully controlled some bacteria such that they may pass the blood vessel wall and infiltrate tumor tissue. The ETH Zurich researchers opted to experiment with bacteria that are inherently magnetic owing to the iron oxide particles they contain. These magnetic bacteria react to magnetic fields and can be manipulated by external magnets. Isn't this interesting?
Yes. If you recall, if the audience recall, we talked about it. We find out those kind of bacteria, right? Bacteria. The antibiotics. How antibiotics, you take antibiotics through your, lung, through your mouth. And how those ones get to the point to target the bacteria. Because bacteria are magnetic, okay? Antibiotics are magnetic. So that's why they attract to each other. It's very antibiotics, the particles, the powders is highly magnetic charged. So now they attract, go through your body and find the bacteria. And what happens when they find the bacteria? The positive and negative, the base north and the south, positive and negative, they are neutralized. So that when bacteria, once it's no longer have a charge, though that bacteria is no longer active. When bacteria active is because it has a stronger charge. When you have a strong charge, you can attract, you can feel, you can be in motion to along the magnetic field. So in this case, this is basically work the same way as called antibiotics. We said, antibiotics has magnetic. They said now we use magnetic. You said magnetic. What do you call this one? You call it magnetic bacteria. So
yeah,
use magnetic bacteria. So that means we have a stronger magnetic field. We can sense it by the instruments. So once we have this kind of stronger magnetic field, can be sensed by instruments. So now we can use external magnetic field to direct. Instead of let itself use weak magnetic field to find each other, take a longer time. Now we can use external magnetic field to direct them to passing the tissue, go inside of the bacteria to attack them. I believe this is a one-step advance. Then just purely use antibiotics and work its way through and find bacteria. And this one use external field and direct them and to them. I believe this could be, this is a major advance. Yes.
That's always interesting to see these developments, how they dovetail with some of the statements you've made about what the body is actually made of. I see another story along this line at phys.org. Positively charged nanomaterials treat obesity anywhere you want. They're talking about these fat cells and the ability to target fat cells and safely uncouple healthy fat formation from healthy fat metabolism would be the answer to many people's prayers. A major challenge in obesity treatment is that fat tissue, which is not continuous in the body, but is found piece by piece in depots, has been difficult to target in a specific manner, pinpointed at the exact location. And they say new studies use cationic nanomaterials to target fat. 2 new studies from researchers at Columbia Engineering and Columbia University Irving Medical Center may have the answer to targeting fat cells deposit specifically and healthily. The papers demonstrate a new method to treat obesity by using cationic nanomaterials that can target specific areas of fat and inhibit the unhealthy storage of enlarged fat cells. The first paper was published today by Nature Nanotechnology. It focuses on visceral adiposity or belly fat. The second paper, published online on November 28th by Biomaterials, focuses on fat underneath the skin as well as chronic inflammation associated with obesity. The team of researchers led by Li Chang, associate professor of pathology and cell biology at CUIMC, and they had unexpected results. So they looked at they took a positively charged nanomaterial called P-G3, and they knew that there was a negatively charged ECM network, which is extracellular matrix, and they injected it into obese mice. The PG3, the positively charged nanomaterial, quickly spread throughout the tissue, and the team was excited that their method to specifically target visceral fat worked. And then something intriguing happened. It shut off the lipid storage program in fat cells, and the mice lost weight. This was totally unexpected given the well-established function of PG3 in neutralizing negatively charged pathogens, such as DNA, RNA, cell debris to alleviate inflammation. Our approach is unique. It departs from the pharmacological or surgical approaches, says Shang, who specializes in obesity and adipocyte biology. We use cationic charge to rejuvenate healthy fat cells, a technique no one has ever used to treat obesity. I think this novel strategy will open the door to healthier and safer reduction of fat. Dr. Yu, you have literally predicted this, and we have the records to show it years ago, using first principles of your much, much more superior theory of physics than anything you hear in the textbooks, folks. You're listening to history when you listen to our show, I'm telling you.
Amazing, yeah.
I mean, you were talking about this use. Can you hear me? You were talking about the use of using charged particles to go after dysfunctional cells in the body for a whole host of diseases.
Exactly. Yeah. If you look at the deeper in the reason they have diseases, it's not just we always those diseases caused by damaged cell. So what kind of damaged cell looks like? It's a leaking materials, right? So and create tumor cancers. So why they can leaking materials? It can grow outside of cells or something, right? It's because it broke the neutralized cell cover, cell shell. It broke that. So in order to repair that cell, so you use some kind of charged particle to neutralize that broken part. It becomes charged. So use another charged particle to make a repair, to remedy, to make it neutralize, and to grow them back. So now the cell becomes a normal cell. No longer can expand it, split, it becomes a tumor. And in this case, they use magnetic particles and go through to the location, to the fat location. Normally you cannot reach them, and to deliver the drugs, or I can use a magnetic field oscillating to generate heat to burn those fat off. Use a magnetic particle oscillation. I believe so. There's so many applications with this first principle application.
Hey, I really appreciate your time, Dr. Yu. It's always great having you on, and I'm not overstating it when I say that this we break a lot of news on this program, and this is a historical information because nobody has chronicled for years so many accurate predictions about physics using a simplified theory of physics like Dr. Yu has discovered. And we've just continually brought the receipts year after year, and I found that story in half a second by just looking up the top news stories of some of the physics sites that I like to look at. It wasn't discussed beforehand with Dr. Yu. Literally, the physics headlines of today and tomorrow will continue to confirm the archive content of A Neighbor's Choice. Thanks for joining us. I'm David Gornoski. Godspeed.